And the Markov chain is called the ergodic Markov chain if it is irreducible and its states are all positive recurrent and aperiodic. Okay, what's the meaning of positive recurrent? So positive recurrent is the probability that any states will recurrent. That means the Markov chain will revisit these states in the future. The probability for this Markov chain to revisit these states in the future is positive. Okay, the probability is bigger than 0. And aperiodic. Okay, let me explain what is periodic Markov chain. Say I have a P. This is Markov chain. And this is 2 by 2 matrix, transition matrix. Let's say 0, 1, and 1, 0. Okay, so this is a typically periodic Markov chain. The period is 2. So why that's the case? So this is P. So if you calculate what is a P square, right? P times P. You can see what's going on here. You got another 2 by 2 matrix, right? And you can have this thing multiply this thing. You got the P square is actually 1, 0, and 0, 1. Okay, this is the identity matrix, right? Now, what is PQ? Right, you can imagine what's going on here because P square is identity, right? So identity times P, so P cube is just P. Right? And then what is P false power? Right, you can see P cube is P, then you just times another P is going to be the same thing as P square, right? Which is identity matrix. Okay. And then you can keep going. I think you already see what's the period here, right? P5 is going to be the same thing as P, and P6 is going to be the same thing as the P square, and so on. Right? It will recursively going on in this way, right? So it's periodic because it will never converge, right? It will be P square, P square, P square, and all the way like that. This is called a periodic Markov chain, and the period is 2. Right. So what is aperiodic? Because any Markov chain that you don't have period, or in other words, the period is going to be positive infinity, right? The Markov chain do not have period. It's called aperiodic. Okay. So basically, the Markov chain most of the time we can make use of the most nicely Markov chain is actually the ergodic Markov chain. Okay. The stationary distribution is also the limiting distribution when the Markov chain is ergodic, right? That's the most important property we need. Okay, now look at this theorem. For an irreducible aperiodic Markov chain, the following statements are equivalent. Okay, which basically means for the most nice Markov chain, A, B, C, they are the same thing. And as long as you have A, you can automatically have B and C. Right? So A says the chain is ergodic. B, the chain has a stationary distribution. C, the chain has a limiting distribution. And when these statements hold, the stationary and the limiting distribution are the same and is positive. The positive means that the stationary distribution pi, it's a pi, right? Pi is a row vector. The positive means this all the numbers in this row vector are positive. So all the probability for this stationary distribution is positive. There's no zero in it. Okay, that's called positive. Okay, that's the most important. Basically, what we want is that what we need in this MCMC is really nice Markov chain where we have stationary distribution and we have limiting distribution, and the stationary is the same as limiting distribution in this case. That's what we need in our MCMC.